Let's look at this question. This is bisection methods. You can see, look at this weird joint, point A. This joint, point A, if you take it by itself, just take it by itself, you can see that there is a force FAB and a force FA, is that N? Yeah, FAN. Let's take just point A by itself. If you do summation force at the X, that's the only force, FAB. There's nothing else, so FAB is 0. If you took a summation force at the Y, there's only AN. So which means that this is 0 and this is 0. So there is no force inside AB and there is no force inside AN, which means that this is for buckling. There's no, same thing here. If you take this joint, this joint G, GF is 0 and GH is 0. Okay? Let's look at the total truss. Find the force in member DG using the method of sections. What is DG? DJ, this one. This one. And he wants the method of section, not the method of joint, the method of sections. Let's find the forces in, well, the point. If you want DG, you need to make a cut in the truss, and you want to take the easier section. The easier sections is, this is two forces and there's one force. Let's find this force at HY and then do the cut here and start from here. So let's draw a free body diagram. So we'll do the cut here to find DG. It's a section cut. And we'll draw it like this. Now let's find the forces in Y and X. And X is 0 because there is nothing in the X-axis. See? The external forces, nothing in the X-axis. So this is in X is 0. No X action forces. Now, let's find summation of forces, summation of moment at where, which one you want. Let's do summation of moment at H equal to 0. You can find NY, and that's easy. And you have all the forces, so you could find summation of moment at H equal to 0. You could find NY, and you could find summation of forces at the Y equal to 0. You could find HY. So summation force of 0 equal to 0, you could find HY. So we have it in 5.833 kilonewton, and we have HY 8.167 kilonewton. Now, let's take the section method. Let's take the section method and the section cut. So, there's two ways. Either you take one side or the other side. Here he took the left side. So in the left side, there is one force, NY 5.833. There is 2 kilonewton at point B down, and there is 3 kilonewton at point C down, and there is this cut. Let's look at the member, this cut. He wants to know this cut. If you took this side, if I were him, I'll take this side, but if you take the right or the left, it will give you the same answer. So there is force DE, there is a force DG, and that's what he wants, and there's a force KG. So there's only 3 forces. Okay, of course, 3, 2, and NY are all other forces. So this is the section. Okay, so now we want to find out FDG. What's the best? And by the way, you need to find the angle 3, 4, and 5. 3 and 4 and 5 is by doing the angles. Let's see. It is DG, it's 2, and it is 1.5. Again, it's 2 and 1.5, it's equivalent to 4 and 3, 5. So 4, 3, and 5. See, 4, 3, and 5. So the best here, remember, X, X, and now we should take summation of moment at the Y equal to 0, because this is X unknown, X unknown. Okay? summation of forces at y equal to 0 to get FDG directly. So summation of forces at y equal to 0, 5.833 positive, minus 2, minus 3, and then FDG in the y, it is either x FDG 4 over 5 or minus FDG 3 over 5. So minus FDG 3 over 5. Look at this. Equal to 0. So you could find FDG 1.388 kilonewton, and it is plus, so it's tension. That's it. You don't need to find anything else. If you want to be nice, you could find the other forces, but there is no need to find summation of moment at D and find FGK and find FDE, but do this for practice. You could do that for practice, okay? But remember, he need only FDG. Thank you.